Hi, and thank you very much for the intro, Bill. I've got the job now of following Mo, who give a pretty in-depth discussion. Lots of those images I could recognise as elements that are embedded into our hardware. So hopefully, I can provide a segue, if not an informative take on mesh network and how we do that at Vortex. Thank you very much for the opportunity to speak here this morning. And as Bill said, I'm going to talk a little bit about the Vortex Mesh Network, what we do with it. In particular, I'm going to pull out perhaps a trend which Mo touched on with Smart City and the explosion in interest that's creating, and that the IoT sort of sector is really beginning to enable. But we looked at air quality monitoring, which, pre-pandemic, if we can all remember that time pre-pandemic, was probably one of the most trending things in technology and from an environmental perspective. And we certainly began looking at that about 2.5 or so years ago, and how we could apply our mesh to that environment. And how that market was served. So we thought it was best served by looking at air quality monitoring from a hyperlocal level. And we coined the phrase, which is really enabled by our mesh, which is about making the invisible visible. I think more people die per annum from poor air quality than died in the First World War, for example. It's a horrible stat, but really puts into perspective what this invisible disease can create. And we know even from the pandemic in recent months that Qom in Iran, Lombardy in Italy, and also the area in China, they had very high levels of respiratory diseases amongst the communities because they were very much in industrial heartlands, etc. So it's something that we've taken seriously, and let me tell you probably a little bit more about that and how we're using mesh and IoT technology to bring that to life for our end customers. Okay, so and why hyperlocal? All right. So there's a little bit of some studies been done in recent times where we can see that across just blocks, that the level of air pollution really changes drastically. Google cars are now collecting air quality statistics, and we know that they provide quite high level of accurate information, but they are spot, so it's taking a reading of a street at a point in time, and it may not return there for months or maybe a year or wherever it may be. So we've looked at those kind of areas, and you can see on the right on those imagery how Google have looked at this and where the discrepancies come from. So if we were going to deploy something there on a permanent basis, so not just a car, but actually getting continuous data from that area, how would you go around doing it? Now, the infrastructure to this, would be the key, and you also need to think about what already exists there. So we've already got light poles, and like any IoT business that's going into smart city, light poles become Christmas trees. That's where you get to make this. That's really is where the land grab is for us, and where we can begin to deploy our hardware and move things on from there. So why would we do that as well, and why would we look to break down kind of the current status quo where we've got cars going around and the cars are showing that we've got high levels of discrepancies and differences across blocks, but currently our cities are often served by 1, 2, 3 sort of behemoth air quality stations, and they're not necessarily reflecting what's happening on the ground. And we know that when we looked into this market, that the vast majority of the growth in the environmental air sensing market in the next 5 to 10 years would come from devices that were fully automated, and continuous monitoring, providing a constant data feed. And there's very good reasons for that. Okay, in that the current hardware, as you can see here, if we got accuracy going up on the left and distance, once you get more than 100 meters away from that weather station or that air quality monitoring station, the accuracy of the data drops up significantly. So therein now becomes another layer of the challenge on how we bring our mesh network to bear upon that, plus our device. Now, we're going for hyperlocal air quality monitoring devices. They're not necessarily the highest level, but you've got a discrepancy now in cost as well. So you're paying either 60K per annum for a complete weather station, or you're paying about hundreds of thousands of pounds per annum for multiple devices deployed around the community to get a far more granular or hyperlocal view of your community. And that's what we set about doing, and therefore we get a far richer level of data from our environment. So this is where we came in, and this is where our Vortex mesh network, our light pole network, becomes the backbone of the infrastructure for that smart city to do hyperlocal air quality monitoring. So as it's already said, the light poles become our Christmas trees, and we place our kit on those as well. So we've got a very long range wireless infrastructure. It's self-healing and self-organizing, so it's part of that cognitive part of technology, which is growing very rapidly. I think Bill said at the top of this session that 2 million devices, additional devices, will be connected to the internet by the end of this morning. I think we've got 100 of those. Okay, we've currently got a deployment going on in South Wales, and I just checked into the team between yesterday and this morning. We have 100, so we're part of that stat. And also, more talked about the explosion of devices. Well, this is where it comes from, really, and this infrastructure becomes the enabler of those of that explosion, amongst others. But the mesh network is just part of it, and we thought about to get the real value out of the mesh, to actually use the edge. Then we needed to create a system. So far more than just a sensing devices. How do you create a system so you can actually deliver value, and therefore your end users are getting data from these devices continuously in real time that they're able to interact with and make sort of evidence-based decisions or interventions. So yes, our system starts with a sensing device. The data is managed at an edge. So typically we have little edge boxes on light poles, and they can cover 50, 60 devices, and then we transport that data across our mesh and present that to a backhaul link into an end user interface. But there we go. So that's the end. The end-to-end system which we have. And perhaps one of the important things of the mesh network and the Vortex mesh network is that we're able to do over-the-air updates. So Mo talked a lot about resilience and security, and that became a sort of a key enabler for us. And because whilst the data we may be transporting may not be ultimately sensitive, if you distort it or hack it, then that's going to be pretty troublesome, because this is actually being reported into sort of government agencies and councils across Council Shire globally as well. Okay. The other element where the mesh network becomes really key in this is that air pollution, for example, has 2 or 3 real key vectors in it. It's dynamic, and it's temporal, and it's spatial. Okay, and then you get the meteorological effects that bring sort of a whole different set of vectors, and then the environmental causes. right? When you put them all together, it becomes quite a complex area, and then how do you then deploy a solution or a system into a smart city that takes into effect these and therefore gives you quality data? And perhaps this next video begins to demonstrate why hyperlocal air quality monitoring is so important. Now we're in London here, which is one of our deployments, and this part of London had one air quality monitoring station that was which was measuring the whole of this area. Well, when you begin to zoom into it, if you look at all the different things, there's a river. We know that the river is causing dispersion of air quality, and then you've got a whole set of buildings which creates different weather situations and wind eddying. So how could one sensor actually reliably give you that information? But at the same time, how do you deploy sensing devices into this environment effectively? That's why the light poles become really important, and that's why the mesh network becomes a really key enabler. So you deploy a mesh network which is low on hardware and low on total cost of ownership to actually scale this environment and provide you with a far more granular picture, so you do actually get to know what's happening. So we know that in this particular part, this is the City of London, the actual square fields, they're actually net benefactors of their neighbours' air pollution. The river causes some phenomenons which brings air pollution down from neighbouring boroughs, but at the same time you've got an airfield not too far from here, the City of London airport. Now you're beginning to separate where these are coming from, and using AI at the edge. We've patented a really cool thing about causal detection analysis. So not only are we giving you the readings of what your NO2 or your air particulate are, but we're beginning to tell you now what the causal areas of these are. And that becomes a very rich form of data. But once again, the key thing is the carrier, which is the mesh, which is able to transport that data. So you can see we've transported that data now, and this is another short video now of an user interface. So we've gone from the device across the mesh, and now we're at just a very short simulation of what that data looks like. We've got 300 devices in the City of London. At least we would have if the pandemic hadn't come in. So we're at the early stages of full deployment. We've done about 6 months of testing. We're growing the mesh iteratively. But you can see this is a picture of the City of London over a course of a week on a time-lapse video. And you can see how the pollution changes over different parts of the day. I think we're going to start off with all pollution, and you can see there's pretty much a heat map going on here of what's happening across the London. We're going into PM10, so that's pretty much harmful stuff which we can breathe in, and see where are the hotspots and maybe where you may want to introduce additional interventions, such as maybe no vehicles, no lorries between certain timeframes. You may want to look at how people are walking to school. A pretty cool thing that we found out through this mesh is that using old reporting mechanisms, a child walking to school is actually exposed to about 3 months worth of NO2, but actually the reporting format that's currently in place means that they only have to report once an hour. And there's very few councils that actually break that reporting cycle on that place. But if you were to walk to school, you would be exposed to about 3 months worth of NO2. But that's all been possible because we're able to get hyperlocal air quality monitoring in place, and then we can help the councils can use our data to actually make intervention. So in the case of City of London, they've introduced more interventions around Southwark and Bank, and being able to back that up with real key evidence as to why it happens. And they've seen drops in the NO2 since post-pandemic. We've seen, as you'd expect, and probably seen on some of the press, the air quality has improved significantly. And then we get to sort of different sort of environments as well here, and again the mesh becomes the key. So this is Port Talbot. In a report about 2-3 years ago, it was got the unfortunate tag of being the most polluted county in the UK. A couple of reasons for this, and if you can follow my cursor, we've got a 7 square kilometre Tata Steel site here. We've got the M4 running pretty much left to right across two-thirds up here. And sandwiched alongside it, or nestled to the left of it, we've got the largest local authority housing estate in the UK. Now, town planners definitely wouldn't make a town look like this today, but this is legacy. You know, the steelworks opened in the 60s. The M4 wasn't too far behind that. And then this local authority housing has grown to serve the 3,500 workforce, direct workforce that is needed here as well. Okay, but some of the things that we found out here through the mesh and being able to get our hyperlocal air quality is that they've introduced variable speed limits across this slice of the motorway. But because of the proximity of junctions, junctions make for more braking, more gear changes, which means more NO2 and more particulate. And we have been able to pick up the discrepancies from the AURN, the actual, there you see around there, that's the actual weather station here. We've been able to get a much granular level of view and demonstrate that actually because of there's 1 to 3 junctions in quite short distance, the actual variable speed limit for the smart motorway is potentially causing more pollution than if it was the normal 70 mile an hour speed limit. Okay, so the questions at play now is, do they maintain the 3 junctions? Do they maintain the speed limit? And on all this type of thing, but that's all done on sort of an enhanced and hyperlocal air quality data set, which we've been able to deploy as a result of the mesh network giving us that ability to connect and create a system across the city. Okay. The other thing we're able to do is create geospatial areas and geofence certain areas so that we know that we can target particular interventions along those. So again, very rich data set created by the mesh. The council in here are also now looking at how do we set about creating a sort of repertoire of runs where we know that the runner can jog and not be exposed to the highest level of pollution that with across that cityscape. So again, you can see how the full end-to-end system begins to help with data intervention that also makes for better places to live, work, and play. I'll just skip over these because again, this is kind of some of the raw data that you get off the mesh. And then we've taken it to another level as well now in recent, in that we're combining sort of parking and air pollution. We spend about 4 days a year looking for parking spaces. And we thought, if you're just going to deploy air quality monitoring sensors, that's just actually giving you sort of not hitting your bottom line from a cost perspective. But if we took detecting the availability of on-street parking and actually classifying vehicles at the edge using AI and transporting that data in real time to connected vehicles or whatever it may, you've got an environmental product that is actually going to, because there's a financial element to it, can revenue generate for the council, but also begin to persuade society to change its behaviours and do things differently. So that's pretty much where we've been focused on the mesh in smart cities, and I think that's about me done, really. I'm coming to an end here. So, yeah, that's been the Vortis Mesh. And as I said, it's a full end-to-end system where you can get any number of devices. In this instance, I've chosen air quality, but we also have a bridge on the end of that mesh, which allows us to bring in Bluetooth, wireless HART, wherever it may be. And again, that's another very key point of this mesh is interoperability built into it. So from a council perspective, that's really good because you avoid vendor lock-in. It's very adaptive. I've shown you Smart City, but the 100 devices we've actually fitted in the last 24 hours actually been in an industrial setting. And then it's very scalable. It's giving you quite attractive low total cost of ownership, and it's available.
Adrian.